Okay, today we're going to go over some of those ionic and covalent compounds. How do we name them? How do we write the formulas and balance them? So you're going to need your periodic table. We have that pinned over here on the left. You've got your polyatomic chart. This has all of your polyatomic ions that we're going to run into. If you're still struggling with identifying what's what, I recommend that you go get a couple of highlighters, 4 to be exact. Pick a color for all your metals. Go through and highlight your metals so that you can identify them. Highlight your nonmetals. Remember, you're looking on the periodic table to see what side of that bold dark line they're on. And then those transition metals, remember they don't follow the same rules, and they use those Roman numerals when we name them, so they need their own color. And then finally those polyatomic ions. Those guys are 2 or more elements. They are going to act as one single unit, so you can't break them apart. And they're going to have their own separate charge, and that's what we need this chart right here for. So number 1, we have already shown how we balance this. So sodium has a charge of +1. We got that because it's in the first column on the periodic table. Fluorine has a -1. We just cross those numbers and it becomes NaF. But this says to name them. So if we look on our periodic table, it says that Na is sodium and F is fluorine. Once it combines, it's going to form an ion, and so we change that ending, fluoride. Remember, if it's an ite or an 8, it's going to be over here on this polyatomic ion chart. So this one right here is 2 nonmetals. So that's a covalent, and we're going to use prefixes and not charges. So those prefixes that we learn, if we just have one of something, we can just name it nitrogen. And then the prefix for 3 is tri. And then F is just fluoride again. Number 3 is another ionic compound. We have lithium oxide. So because it's not covalent, we're not using prefixes. Remember that. Another ionic compound, we have aluminum and sulfur, and they form aluminum sulfide. Here we have magnesium. But remember, I told you to watch. If you have 2 or more capital letters together, that means that it's a polyatomic ion. So essentially, there's parentheses around this. It acts like one individual unit. So we're going to come over here and we're going to find SO4. Right here, it's sulfate. And then number 6, we have Si, which is silicon. And then I've got H4. So that one is, remember we talked about hydrogen? If it's acting as the anion, we're going to call it hydride. If this was a nonmetal, then we would do the tetrahydride. Here we have K, which remember is potassium. It's a metal. It's not phosphorus. And then that NO3, remember, that's 2 or more capital letters, tells us we got to go look at the polyatomic ion chart. So NO3. So we find it over here, it's nitrate. Now we have 2 nonmetals together. So we're going to use those prefixes. So 2 means di, and a P is phosphorus. So diphosphorus. And then 5 is penta. And then the O, oxide. Now we have Ca, which is calcium. And then we've got this OH. So we come over here to our chart and we find OH, and that is hydroxide. Calcium hydroxide. And that's all there is to naming those. You just have to pay attention to whether you're mixing metal and nonmetal, or nonmetal to nonmetal. And then are there polyatomics. So the next thing on here, we're going to look at writing these balanced formulas. So nitrogen. Sorry, I skipped number 10. Lithium chloride. So lithium is Li, and chlorine or chloride is Cl. So we can do the same thing here with those metals and nonmetals and our transitions and our polyatomics. We can look, and our metals are orange. Nitrogen's not a metal. Lithium definitely is. Sodium is. Ammonia is not. Potassium is. And then those nonmetals, chloride, nitrogen, trichloride, oxide, nitrogen, trioxide, phosphide. So what is this ammonia? If you look on your periodic table, you're not going to find it. That's because it's on this common polyatomic ion chart. Ammonia is one of those polyatomics. So now we're set up, we can get going. So lithium is a metal, so it's got a charge of +1. Chlorine is -1. We cross those charges, so we have LiCl. Nitrogen is N. Trichloride. Remember when we're dealing with those nonmetals, there are no charges, so you're literally just writing Cl. You go back, and that's a 3. That's it. Sodium, Na, and oxide is O. Because it's ionic, it's not balanced. So sodium is a +1 and oxygen is a -2. You cross those and it becomes Na2O. Next we have dinitrogen trioxide. Our nitrogen is just an N, and that prefix di means 2. Oxide is O. Tri is 3. That's all there is to it. Now ammonia, remember we highlighted, that's a polyatomic. We come over here, it's just NH4. And just as a side note, it has a +1 charge, so we'll see that with other combinations. The last one on this page, potassium. Potassium's a K, it's a metal, and phosphide is P. So a lot of times we get those confused, so make sure you're paying attention. The charge for the potassium is a +1 because it's a metal, and the phosphorus is a -3. So in order for this to be balanced, we cross those, K3P. Next, we have some polyatomic ions. They're going to work the same way. We're going to use this chart. So magnesium is our metal, Mg, and it has a charge of +2. Nitrate is one of those polyatomic ions, because remember, if it ends in ite or ate. So I come over here and I look. Here's nitrate. It's NO3. And it has a charge of -1. So what that means is when I go to balance this, I can't just write my 2 here, because then that looks like 1 nitrogen and 32 oxygens. So I'm going to put my parentheses in to separate them. That says that I have 2 nitrates for every 1 magnesium. So we rewrite that, MgNO3, the 2 on the outside. Then our aluminum carbonate, Al, it has a charge of +3. Carbonate, we come over here, is CO3, and it has a charge of -2. So again, we're going to have to draw those parentheses in, and it's going to become Al2, because remember that one comes down here, and this 3 has to come over here. Next I have potassium oxide, K and O. Potassium has a charge of +1, oxygen's a -2. I'm going to crisscross those, and it's going to become K2O. Next I have my copper 2. That Roman numeral 2, remember, tells me it's a transition metal. So copper is Cu, and that Roman numeral tells me it has a charge of +2. Chlorate has that 8 ending. That tells me to look on the polyatomic ion chart. And if it seems overwhelming, it's going to get easier because you're going to use these more and more and more. So we're going to look for chlorate, and I see it over here. It's ClO3, so chlorine and oxygen. And it has a charge, because it's in this column, of -1. So I'm going to rewrite that as Cu, parenthesis, ClO3, and parenthesis 2. And that's it. That's the balanced chemical formula. Our last one, cadmium hydroxide. Cadmium's a tricky one. Even though it is a transition metal, it's right there in the middle. It only has one form that we deal with. So cadmium, the top of its column is Cd, and it's a +2. So everybody in that family is a +2. It's a zinc family. And then hydroxide. Remember, that's not going to be found on our periodic table, so we have to look on our polyatomic ion chart. We come over here, we find our hydroxide. It's an OH. Put my parentheses. OH is in this column of a -1. So that's going to become CD. That 2 comes over here. The 1 goes over there. OH2. Now, why is it important that I put those parentheses there? Because if I don't, it looks like that. And that's very different. This is saying I have 2 oxygens and 2 hydrogens. This is saying I have 1 oxygen, 2 hydrogens. That's not what we want. So we have to include those parentheses. This is going to be relevant in the next chapter, because then we're going to start combining chemical formulas and seeing what happens when we mix two things together. Who's going to take whose place? Who's going to get kicked out?